Assalamualaikum warahmatullahi wabarakatuh, and a very good day to the all presenter and researcher that has been with us today. First, let me introduce myself. My name is Mama Hatta bin Hatta. Currently, I am a first year PhD student at Malaysian Japan International Institute of Technology, University Technology Malaysia, Kuala Lumpur, under supervision of Dr. Faizah Cik Ros and Prof. Aminatul Mato. So this study has been sponsored by Japan Home Shield and Mr. Gosakai as their representative. Today I will share to all of you the study of correlation between the result of screw damping sounding and Macintosh probe test. As the background of the study, as we all know, the drilling of the borehole usually takes more than 1 day, and it uses a lot of fossil fuel due to the size of the machine. So we also need to pay about the transportation, the drilling itself, and for the lab test. So we need to catch up with the new technology and support the Industrial Revolution 4.0. So right now, the Japan has been developed the screw damping sounding together with the Tokyo City University, Japan Home Shield, and the Nitto Seiko Corporation. So this machine is a small equipment that use minimal energy to operate and can carry out by one person, and it use the Internet of Things, IoT, which is the cloud data system. However, this machine needs to correlate the result with the conventional methods such as SPT and the MPT, because it had not been used in Malaysia. So at the 2017, there has been a joint R&D between the Japan Home Shield and UTM itself. So for the SDS equipment, this is the front view of the SDS equipment, which is in the test mode. So you can see this is the side view, which is the transfer mode. This equipment measured and recording the data at site automatically, so it not been influenced by the operator skill. So this we can see in the picture here. The machine is very compact. We can disassemble it and load it into the van. So in Japan, they can survey from 5 up to 10 sites a day, and the depth of survey point is about 10 meter. But in Malaysia, we managed to do 2 sites per day, which is one in the morning and one is in the evening. So usually the depth of the penetration is about 15 meter. So for the data cloud system, as I mentioned before, first we need to set up the machine at the site, and then the Bluetooth and the GPS will be on automatically. So at every 25 cm penetration, the data will be sent to the cloud from the control box, and then after the test has been done, we can download it through the mobile phone, and we can rename the file in the cloud system for easier of our reference after to do the analysis. And then we can immediately get the graph of the corrected top and load and the velocity. So we can compare the corrected top with the graph of the SPT. So we can see the trend. So usually we will do 2 and up to 3 tests per borehole or per MPT, so that we can see the same trend, and we can determine either to further the test or we can stop the test. So the another advantage is the other team members that has not been at the site can also see the data, where they can download it from the server, and they can give their comment even though they are in the office. So in the studies, we want to correlate between the MPT and the SDS. As we all know, in the field, the Macintosh prop test usually use a minimum of 2%, which one to record the reading and one to do the test. So this is not a practical working environment where the one need to stand for a long period of time, and is usually have a human error which to calculate the penetration blow. So for the SDS, it is as I mentioned before, it is automatically been done, and it has stable measurement accuracy. For the study, it will cover up to 40 sites at various states around the Peninsula Malaysia. But for today, I will only present to you the result at the Putrajaya, which is at Presint Smith 9. This is the picture of the test being done at Presint 9. We do 4 tests here, which is 2 at borehole 1 and 2 SDS test at MPT 1. For the comparison of the data, the MP1 has been compared with the data from SDS3 and SDS4. The soil profile from the nearby borehole 1 also included in these figures. So as we can see from the SDS3 and SDS4, around 4.5 meter, we can detect a hard layer of soil around 1 meter until 5.5 meter. Around 7.5 meter for the MP result, the data keep increasing, and it's end at about 10.5 meter. While you can see the SDS, so the data is still quite soft until 10.5. As we can see from the SPT, the result of SPT shows that the soil layer is still soft until around 15 meter. So actually for the SDS, maybe it can still penetrate until 15 meter. For the analysis part, so as we know, the MPT is done for every 0.3 meter, while the SDS is done by every 0.25 meter. So for the data at 0.3 meter, we will compare with single data method, average 2 method, and average 3 method. So for the single data, the 0.3 data will be compared with 0.5 meter SDS data. So for the average 2, we compare with the 0.25 and 0.5 meter of the SDS data. And for the average 3, we will compare with 0.25, 0.5 and 0.75 with the 0.3 meter of the MPT section, and so on until the finish of the MPT data. So this is the result and finding. This is the combination with data of the two tests, which is the SDS3 and SDS4, and we can see the coefficient of estimation, the R squared, is quite high. Is minimum is 0.4, and the R is more than 0.6. So for the best correlation is the average 2, is has R squared of 0.4851, and the R squared of and the R of 0.69. So this shows the MPT and the SDS has a high correlation between each other data. And as the conclusion, so the attempt to correlate SDS and the MPT test has been considered successful, because we got a quite high R squared, which is higher than 0.6. That's all from me. Thank you for your attention.